This video will prepare you to start doing inferential statistics by looking at the methodology behind surveys and sampling. It is usually highly unlikely that we have access to population data. In today's world, there is a preponderance of data. To make better decisions in business, you will need to know as much as you can about your market. In other words, a specific population of people. This is where samples and sampling come in. We are going to make an inference about the population based on a relatively small random sample. The key word here is random. Let's start with some more basic terminology. A population is all of the people or items that you want to get information about. A sample is a subset of that larger population. The instruments that we use to get information from a population or sample are a census or survey. You may be familiar with a census that is often used for obtaining population information every 10 years or so in various countries. A parameter tells us something about a population, like the mean, or in this case, population mean. And population parameters are usually written with capital Greek letters. A statistic tells us something about a sample, like a sample mean, or X bar. That's X with a bar over it. Now, we are ready to create a survey and take a sample. Let me talk for a minute about surveys. They are hard to do. I suggest doing the following. First, determine what data you want to obtain. Second, try and find other surveys that are similar or have similar questions to the ones you want to ask. Third, write several drafts. Fourth, pretest the survey with a small group. Fifth, revise and do another pretest with another group of individuals. The next step is to draw a random sample from the population. Here you need to start with a population frame. A population frame is a listing of every person or item to be sampled. Then you need to draw your sample. I will talk briefly about 3 sampling methods. The first is a convenience sample. With this method, you just find a bunch of family or friends and give them the survey. It is not representative of the population and not a good way to do sampling. The second is a simple random sample. Here, a pure random sample is taken from the population. I will demonstrate one method to do this in the next video. The third is a stratified random sample. Here, the population frame is divided into subgroups to ensure representation of key demographic categories. For example, you could break marital status into never married, married, or divorced. The next issue to be aware of is survey errors. There are 4 you should be concerned with. 1, coverage error. In this situation, your population frame may not actually be representative of your true population. This is often called selection bias. Then we have a non-response error. This occurs when a survey respondent does not answer a question or provides a nonsensical answer. Next, we have measurement error. This often occurs when you perform your own survey and cannot read the respondent's answer, or you may mistype the respondent's answer when entering it into the computer. And fourth, sampling error. This is the trickiest error of all because it may occur when you've done everything perfectly. A sampling error may occur because your random sample does not adequately represent the population by pure chance or bad luck. At this point, you should have administered your survey and are ready to score the results. Our next task is to cleanse the data. This can often be the most time-consuming task to perform. I mention it because most individuals do not realize how painstaking of a task this is. Here you encounter measurement errors, missing values, and identification of potential outliers.